Good morning, everyone. Thank you for joining us as we wrap up our Tech Talk series on industrial networking. This is part 6. We will be discussing securing the industrial control systems network with CIP Security. I'm Brandon Singh. I will be your presenter today. On the line with me, I do have some panelists who will be monitoring the chat and Q&A. For any questions or comments you guys want to throw in there for us. I have Joe Bolesky, who's an automation specialist, network specialist with the Reynolds Company out of Houston. I have Mark McGinnis, who's an automation specialist out of the DFW area with the Reynolds Company, and I have Wayne Welk, who is a automation specialist with the Reynolds Company out of New Orleans. So just some upcoming events that we have coming up online with the Reynolds Company. We have our users group in July 16th. Our users groups are a little bit longer than our tech talks. Our tech talks are designed to be 25 to 30 minutes. Our users groups are usually about 45 minutes to an hour to go a little bit more in depth. And our next one coming up is in July on the 16th. We'll be discussing the My Rockwell Automation portal and the software portal. Some upcoming tech talks we have coming up. We have tomorrow, we have intrinsic safety barriers with the 931. And then the following Wednesday on the 1st, we'll be discussing automatic device configuration with PowerFlex drives. And then we have also started a podcast that you can find on all your major streaming services, Apple Music, iTunes, Spotify, Google Music, Play Music. We discuss different automation topics and in the industrial plant floor. We have a new one dropping this week. So today we'll be discussing CIP Security Protocol, Defense in Depth. Agenda that we'll be running through, specifically why do we care, why do we need CIP Security, what does it do, how are we implementing it, how to approach it in phases, and then we'll wrap up with the Q&A at the end. So why do we care? For several years, we have been talking about the value provided by a defense in depth architecture, the CPWE, and this is still a very good recommendation. We want everybody to implement it as best they can, but it's no longer good enough. Security researchers have found that have criticized industrial control system communication protocols of the past, Profinet, Modbus, Ethernet IP, for their lack of several key security priorities. The most important one is authentication on messaging. And security can be a very integral part of data, and if we don't have proper authentication, data can be changed. It offers CIP Security offers the advantage of it being confidential, and it solves the problem by adding these priorities to Ethernet IP and allow the automation devices to defend themselves. So these are the 3 different ways that a hacker would attempt to steal some data from the plant floor. A direct connection, they directly connect to an open port or that they find on the device floor, whether it be inadvertently someone just plugs in their phone, or they inadvertently plug in their laptop, or they're doing it on purpose, or we have what we have called man-in-the-middle attacks, where someone attempts to hack into the network and steal the messaging as it's being transferred back and forth. Or we have the last one, which is the monitoring the data, where somebody is just actively looking at your data as the traffic is being sent across. So secure communications, what CIP Security Protocol actually provides is a secure transport of messaging across your Ethernet IP network. It was developed by ODVA, formerly known as the Open Device Net Vendors Association. And specifically, what it does is it rejects messages that are sent by untrusted people or untrusted devices or an untrusted source. It helps prevent viewing of Ethernet IP data by unauthorized parties, so keeping everything confidential. And then it reinforces the defense in depth strategy by providing multiple layers of security against a more resilient attack. And each layer adds upon the one before it. So here are basically that layer of security that the CIP protocol puts in place. So device identity, there are digital certificates that are provided to secure the IDs of each device, so you know the specific device is supposed to be sending you messages. You have device authentication. This is done through transport layer security, TLS, and it's also done through datagram transport layer security, DTLS. These protocols are used to help secure the message as it's being moved across the network. Data integrity, that's done through key hashed message authentication code, also known as HMAC. Again, that's another method of providing data integrity and securing the message that it's only being authorized to be opened by specific devices. And that also goes on to the next layer, data confidentiality. Again, that's encrypting the data, encoding the messages with specific codes that is tagged to the message, so that when it's received by the end device, it knows specifically this was sent by the correct party, and it's allowed to open it because it knows the code that it's looking for. And if it doesn't see that code, it's not allowed to open. It doesn't open the message. So how, leveraging technology to provide how this is done, it is almost identical, as you see on the graph to the right, to when you're going to banking websites or any trusted secure website where you have to log into that website. You always get that little lock on your web browser bar at the top, your address bar. So we put that on to the right to show you that all your major internet platforms are using it. And how it works is the client device sends out a message that says, "Hey, I need to set up an encrypted session." Whatever it's reaching out to sends back a key, which is the access the code in the messaging. It sends a response back saying, "I would like to see your certificate," and again, it's secure communication back and forth to establish and create that code for authentication to read the messaging before the messaging is already sent. And you'll see that that's explained in the diagram on the left with all the different arrows going on. So here on the bottom, CIP Security Protocol is enabled, and something can be used on the current devices: Factory Talk Links, Control Logix 5580, 1756 EN4TR, PowerFlex 755T drives, Kinetics 5700, and the CIP Security Proxy, which is something we would use for secure applications, such as your Factory Talk activation manager that reaches out to Rockwell's website to get product lifecycle updates and see if something needs to be updated that we've discussed in earlier tech talks as far as securing via the cloud. And all of these devices, again, go into protecting the identity, integrity, confidentiality through the CIP protocols. So identity authentication. So specifically here, what we're looking at is we're looking at Factory Talk links and the communication to the 1756 EN4TR. As that communication is sent back across, as I said, it looks to establish the connection and the key, so both parties know the code and the key to unlock that code, so it can actually read the encrypted messaging, and it's through a secure line of traffic. So one way a hacker might be looking to retrieve that information that's being sent across is, as we said earlier, directly connect to your 1756. However, when he connects to it, he's unable to actually look at the messaging being sent across because he doesn't have the appropriate certificate, code, and keys to look across. So he sees the traffic being sent, but there's nothing he can do about that traffic. So when the hacker tries to send a command to the controller, it wouldn't work. He wouldn't be able to send any type of command to the controller or send false messaging back to your factory talk links because it doesn't have the appropriate authentication codes, and that was established between factory talk links and your 1756 in 4TR. So another way this is established, as I said, with that messaging is through HMAC or hash message authentication code. The message is first hashed, as I said, to provide integrity. It's a secure key that is established, added to the message before it's hashed to provide the authentication of who it was sent from. You can't validate the message unless you know the secret. So unless you know the specific key to decrypt the message, it's not going to be able, it's not going to do you any good. It's very fast and efficient with only very, very minor performance implications to set this up. Another way that CIP protocol helps secure the plant floor is through integrity. Now, you have a hacker who's not able to modify data, however, it can still view the data, which is why we put in the integrity piece. So it helps prevent tampering or modifying the communications. As I said, the first part helps him from changing any of the data, but he's still able to see it. The integrity portion helps with that. The encryption, by encrypting the message, that way it's encoded messaging information to help prevent the reading or viewing it. So now with the integrity portion of it, he can't alter the message and he won't be able to view it now. It's completely optional. Not all ICS traffic contains secrets that need to be safeguarded. Data integrity and authenticity is typically the goal, but this is an added encryption that will impact data throughout the performance. And the last one is confidentiality. It helps prevent the snooping and disclosure of the data. So with implementing all three of these pieces, that hacker is then rendered useless and not able to get to the information on the plant floor that's being sent as messages across. So what exactly am I securing with CIP Security protocol? You're securing the Ethernet IP port itself. Dual IP ports can contain different security configurations. So as you see, you have on that diagram, it's showing the 172.300 IP address on that port is secure, which is why it's green, and you have your lock just as you would on your internet browser. But your other port, your 192.168 port, and this diagram is rendered unsecure, which is why it's showing red. So just an overview of CIP Security protocol. As I said, it provides authentication, helps prevent unauthorized devices. Integrity helps prevent tampering and modification of communications. Confidentiality helps prevent the snooping and disclosure of data. It is system management. It's easily to create and deploy the security practices to many devices. It's micro-segmentation, your automation appliance application to just smaller zones. So if it's a specific zone where it has it needs to be more confidential than a different zone, you can implement that differently in the different zones. It's a device-based firewall, so you're able to enable it and disable it on different ports and protocols, very similar to setting up a firewall and to go out to the internet and making sure you can't go to a website that requires HTTPS, which is where you get the lock on your web browser, and then a regular web browser where you get your HTTP, where your web browser doesn't have a lock. It does have legacy system support, so trusted IP, authorized specific communications and IP addresses, and we can retrofit 1756 based on systems with the new 1756 EN4TR. So configuration, how would you configure CIP Security. So we're going to manage CIP Security configuration from a central authority point. In this picture, you can see the authority. Authority is responsible providing device with secure identity and its policy. In this example, the policy is a simple way to tell the devices who they should trust and who they shouldn't. Specifically, we're using Factory Talk Policy Manager software at your computer at the top of the diagram, and then through the Factory Talk System Services Platform policy, you're able to push that down to your workstation on the plant floor, your switch, all the way down to your drive and your HMI. And you can break this off into zones, so you know that this zone of your plant is connected and secure and encrypted. And all security changes are first configured using a security configuration tool and then distributed from a central authority to the affected devices. This dramatically reduces the chance for human error by allowing this security configuration to be modeled or molded and deployed consistently to all devices without any changes. And once it has been deployed, your Factory Talk Policy Manager and the Factory Talk System Services Platform are no longer required. So once it's deployed, you no longer need to have those continuing to run unless you're adding more changes to be made. But if you're not adding anything, then you no longer need those things to run in place. It'll continue to run itself with the secure setup that you put in place. So this is a sample deployment. This will follow the same. This follows the same setup as we just discussed, where you have your Factory Talk Policy Manager software and your System Services Platform at the top, and you use those to push out to the trusted zones. And once done, these are the 3 zones that you would set up on this deployment. Where you're off to the right, you would then have your PC zone, where you have your Studio 5000 software and your Factory Talk View software, and then you have your 2 zones down on the plant floor for the different areas. They're calling it Conduit 1 and Conduit 2, but you have different security implementations in place for each zone or line, or in this case, they're labeled Conduit 1 and Conduit 2 that you put in place specifically for what can communicate with what, and its secure traffic, as well as that segmentation that we're all looking for. And some things to be aware of on the initial release. CIP does not support protocol bridging, so you can't configure CIP security through a CIP bridge. It does not support high availability. It does not support network address translation, or NAT, unless the map is used mapped to a public IP address. It does not support automatic device replacement, or ADR, and supports only 1 NIC if multiple NICs are available in the Factory Talk Links software. So some use case scenarios: secure configuration controller, computer to controller, secure the inbound connection via 1756 EN4TR module or ControlLogix 5580 controller itself. Again, at the top you have all the locks at the top between your Factory Talk View Studio software and your Studio 5000. And then as you move down, again, it's all secure communication to the controllers and to the HMI. That's why it's all in green, and you see the green locks. So as far as the release schedule, available now is your Factory Talk Policy Manager software and your Factory Talk Services Platform version 6.11.0 or later. Your ControlLogix 5580 controller is available now. Your 1756 EN4TR ControlLogix communication module is available now, as is your Kinetics 5700 turbo drive. Upcoming is the CIP Security proxy. Original target was for Q3 2020. I believe that's been pushed back a little bit due to COVID, and the PowerFlex 755T drive was targeted for Q3 of 2020 this year. So here are some white papers and design guides that were recently released regarding CIP security within the last month by Rockwell that goes over everything more in depth on design, implementations, and white papers on how to best architect your CIP security into CPWE architectures. Do we have any questions in the chat?
I do not see any questions in chat.
Thank you, Mark. Thank you all for joining us for this. Again, if you have any questions regarding CIP security, please reach out to any of your automation specialists or network specialists in your area, whether that be Southern Louisiana or in Texas, whether it be Wayne, Joe, Mark, or myself. We look forward to helping you, and thank you for joining us.